We're live.
Okay, I think we can start right now.
Yeah.
Okay.
Hello everyone on the next AWS User Group Poland meetup. This time the meeting is conducted in English because we have some foreign guests with us. So welcome Michał, welcome Darko, and welcome Jacek. It's nice to have you here, and it's nice to have you listen to the presentations from you.
Thank you for having me. This is one of the things, first time speaking in Poland, so thank you very much for inviting me, finally.
Yeah, nice. It's nice to have you here. Thanks you. First thing first, let me know if the audio is okay and the video is okay, and you can write the comments in the YouTube channel. To make sure that communication between us is fine. Okay, there is some delay, and Wojtek agrees that finally Darko is here. Okay, nice. So I think we can go next.
Okay.
I will introduce myself. My name is Wojtek Dąbrowski. I am one of the AWS User Group Poland leaders, and I am organizing the meetups like this. This time online, but I hope that soon we will go back to the offline meetings. I hope so. I am also AWS Community Builder. This is the new AWS program for active community people. The previous edition was run around the November, and we are right now after the second one scheduled sign up. So soon we will have another AWS community builders with us. Besides that, I am working in the pattern match as a cloud architect. And if you have any questions regarding the AWS community, AWS user groups, and so on, you can reach me out in LinkedIn and in GitHub or in Twitter. So don't hesitate to have any questions regarding these topics. The short agenda recap for our today's meeting. First, we will have a presentation from Michał and Jacek from Jamf. After that, we will have the Q&A session. After the Q&A session, Darko will present, and as well we will have the Q&A session for this presentation. Regarding the questions, I encourage you to ask the questions in the YouTube chat, so we will ask them and answer them after the presentations. Okay, so let's start with the first presentation from Jacek and Michał, and the stage is yours, guys.
Thank you, Wojtek. First, thanks for inviting us here. Today, I would like to talk about Jamf and our Bumpy road to cloud-native business, and also why we are so focused on architecture to make it happen. Yeah, short introduction about ourselves and also Jamf. My name is Jacek Tomasik. I work in cloud and delivery in EMEA, in Jamf. And together with me, we have Michał Popowski, who is our cloud architect. Regarding Jamf, Jamf is a US-based company, headquartered in Minneapolis, in United States. 1,600 people globally. In EMEA, we have 150 people. In Katowice, sorry, 150 people. And also we have a second European hub in Amsterdam and Emmen. And what we do? Generally, we are specialized in Apple device management, and especially Apple device management in enterprises and all of the companies and organizations which decided to use Apple in their organization. Some numbers, we have 47,000 customers, and as at the end of last year, we reported that our software managed 20 million devices around the world. Yeah, before I start to talk about our journey, I would like to a little bit introduce my own cloud journey, which is kind of background to what I would like to present later. Because I started to work with cloud in 2012, and that time based on some marketing materials and high-level description from, let's say, providers and also some, let's say, influencers, I thought, okay, cloud is extremely flexible, it's extremely cheap, it's scalable, fault-tolerant, and secure by design. It means that more or less it's time to say goodbye to architecture, because we don't have to architecture anything. Because if we just make a mistake, we can make it different way, without cost, without any impact, quickly, and generally as smooth as possible. After a couple of years and let's say this relatively long cloud journey, I see that the situation is a little bit different, and I would like to today present our journey and also emphasize why architecting matters on every stage of your potential cloud journey and every organization which decide to embrace cloud closer. Jamf Cloud history. Jamf has developed Apple management software since 2002, what means that it's a company with almost 20 years of experience in this field. But a couple of years back, our customers started to ask us to deploy our software somewhere and deliver them software as a service experience. You can imagine that number of customers like schools and other departments without strong IT, they just don't want to cope with all of the problems related to any software hosting, because they would like to be focused on management of their desktops. And also it means that they prefer to use it as a service instead of dealing with another type of technical challenges. And in the first iteration, we did exactly what our customers did. And we just installed first applications for our customers, application server, database server. We exposed it to them through the internet, and history began. In next iteration, we realized that it's working fine for one customer, 10 customers, but if we think about 100 customers, we need some automation. And then my colleagues worked on a number of different automation approaches. They started with Bash, Python, and finally landed with Ansible. And for the scale, automation is a key. In third iteration, we expanded outside to US. And that time we realized that we need to somehow reproduce the setup which was done in US. And the goal was to do it exactly the same way or similar way to reuse automation, because we cannot just afford to have different setups in every region, AWS region, to support customers in different countries. Due to the fact that it's less and less possible to manage it at such scale manually. And here there is a first lesson learned which I wanted to share with you. From very, very beginning, you have to, if you think about your application and or let's say just cloud setup and how you would like to, let's say, succeed, you have to think about automation and plan for automation from very, very beginning. Because sometimes people start the cloud setup manually with just some number of items, and it's growing naturally, but sometimes exponentially. And it's very easy to find the way, to find the spot where your initial setup is not relevant to operation at scale. And in this case, advice is think big from the very beginning. Plan in advance as you can. Assume you will expand globally. It means that everything what you can predict, try to predict at the very beginning, starting from naming convention, infrastructure as a code to make it repeatable, tagging, IP ranges, AWS accounts. I remember that a couple of weeks back we had such a presentation about AWS accounts, and it really matters to try to predict everything what is possible. Two examples. First, I work in an organization which developed naming convention, I don't know, 10 years ago, and it's still valid because it was flexible enough. Yes?
Sorry, I will I will stop you because probably you are not sharing the correct screen because we are still seeing the presentation and it's not in the presentation mode, or it is just us.
Sorry, it was in presentation mode, but I don't know what's happened.
Okay,
what do you see now?
Maybe the screen freezed, but okay.
Because on my side everything is smooth.
Okay.
If you can tell me what you see.
We see the screen with Keynote.
Yeah,
but not in the presentation mode.
And now, because it was all of the time in presentation mode.
Okay, so that's strange because even from our side it's not.
Okay, guys, it will be more difficult, but because 1 second, I will try maybe to do it again. Yeah, it's okay. Let me share it again. Stop. One second. What about now?
Perfect.
Okay,
now
let's try. I hope that it will work.
Presentation mode.
Okay. Going back to examples. First one is a good one from company where I worked before. Developed that when we developed that time naming convention, it was flexible enough to survive for the next couple of years. And second, bad example, because when I worked in AWS and AWS introduced Transit Gateway, a number of customers start to ask, okay, how we can use Transit Gateway with overlapping IP ranges in different VPCs? It means that, it's a significant problem because people just didn't plan that, solution like this will be there. And just again, to emphasize, whatever you can plan, try to do it in advance. Okay, next problem, which I would like to describe here quickly. I would like to talk about large-scale planning and management. We have, using AWS and general any cloud type of service, you have to plan in advance not only technical solution, but also cost implication. Because as an architect, you cannot expect that there is anyone else in your company who will deal with that. And AWS is great because it's flexible and you have a number of choices, but from other perspective, it's a nightmare because you have to make those choices. And we have a number of instance types. We have even 3 different CPU types in AWS, AMD and Intel processors, and recently ARM. Also, we have to right size environment just to pay for what we use. Even small thing like component placement in certain availability zone is very important because, as example, you can use 2 application servers in A zone A and B, and if database is located in availability zone C, then you pay additional for inter-AZ traffic. Maybe you can reduce it. And next choice, which is very important, is to use managed services versus use something with own maintenance, like EKS. You don't have to use EKS. You can install Kubernetes your own. The same with RDS as a database and Elasticsearch as an example. Also, additional problem is related to purchasing option, because you can use on-demand, spot, reserved instances, or savings plan. All of those choices which are available to you, it's very universal. You can do whatever you want, but everything is on architect's shoulder, and you have to make decision by yourself. Because in this case, depends on your decision, it's significant impact on your bill. Because if you make a wrong selection, you can quickly double or triple cost. And probably if you have environment which costs you, $100 per month, it's for development purpose, it doesn't matter, probably you will survive it. But if you operate any kind of large scale installation and you made one wrong choice, you can increase your monthly bill by thousands of dollars. And this is really important to be sure from the very beginning that you plan it optimally. And also, if you plan it optimally at the very beginning, it matters, but also you have to track or follow what AWS offers and what recommends, because offer is changing every couple of weeks, and choices made a couple of months back could be not longer optimal today. And this is our second lesson, which we wanted to share with you. Next steps, we decided to go to containers world. One of the main reasons was that our application is live, and we have a number of deployments of the new version per year. And doing that in, let's say, classical environment is pretty painful, time-consuming, and makes some troubles. And together with containers, we just face new challenges, because it looks very easy at the very beginning. Okay, containers, let's do it. But if you take into account the scale, it really matters what kind of solutions you select. Even simple thing like, for our scale, we cannot use only one cluster, EKS cluster. We need to use number of them. And again, we cannot deploy them manually. We have to deploy them number of times per year because the upgrades and different changes, and everything needs to be automated from the beginning to the end. And actually, it looks simple, but devil in details, and you can spend a lot of time just on planning that and implementing. One of the significant problems is continuous upgrade process. EKS is supported only for 40 months in AWS, and you can expect that you'll need to upgrade it every couple of months between the versions. And even you have automation for upgrade process. From time to time, something can be deployed by AWS that way that you have to change your automation because, for example, upgrade in place is not possible. Also, it's related to all of the add-ons to the cluster and even AMI versions which are supported there, because there are different types of how it could be, how you can upgrade automatically or semi-automatically AMIs for worker nodes. And also here we face some additional issues. In the past, all of the application logs was, let's say, somewhere on the EC2 instances. Now, as we use ephemeral infrastructure, which can just disappear, and we still need to have logs, we had to implement especially logging infrastructure. And also here, number of analysis was made, and Michał was the guy who did it. And between the cheapest and most expensive was the difference 10 times. And the problem is that in many cases, if you don't think about scale, you just go based on some patterns, something what you know. Like people think, okay, logging means Elasticsearch. If you ask somebody else, somebody with different experience can tell you, okay, logging means Splunk. But again, if you multiply by, let's say, scale, then between those choices or something else could be few or even 10 times difference in price, and also functionality matters here. Also, next problem with monitoring, because you can use something open source, you can use monitoring from AWS, you can use from third-party providers. With open source monitoring, you have to spend number of hours on adopting this, upgrading, and actually entire knowledge which is behind the scene related to monitoring, you have to build by your own. Buying a monitoring platform, I don't want to use any names because I'm not here advertising anything. You not only buy the solution, you also buy the knowledge from somebody who did it before. Also, next point, automation, because our entire automation designed for EC2 fleet is not longer valid for containers, and had to be rewrite from the scratch to meet the new requirements of the containers world. And third lesson learned here: modern is not always equal to easier. Number of technologies, if you just read it at the very beginning from the marketing materials, everything is very optimistic, sounds perfect, but devil is in details. Also, scale again matters, because if I think about like Docker using containers, this simple containers as a Docker on the workstation, it's perfect for me, because I don't need to install any virtual machine, I don't need to install any software. I just take something from Docker Hub and it works. But it's not the same way for the large scale, and you have to predict it. And then be open and be flexible and plan it before you decide to go anyway. And new era, cloud native. I meant in the title about cloud native business, but we even didn't touch this point. And what kind of challenges we also face here? Because we have some applications which are already which has been already cloud native. Some of them was kind of traditional one, and we have to decide what to do next, because we cannot just say to our, say, traditional customers, okay, you have to use cloud. In number of businesses, cloud adoption is still not the case. You cannot tell all of the financial institutions, some government agencies, that they have to go to the cloud to still use your software, because their requirements are pretty different. Even some schools in some countries, they have a number of requirements related to data protection of their students. And you have to take care about that and be sure that you meet all of the requirements. And for that purpose, it's kind of impossible today to say that it's cloud business or non-cloud business. And then we have to run both. And this is typically customer-driven dilemma, because we would like to support all of the customers, and then we have to live in those two worlds. But Michał will later tell you a little bit about our, let's say, some cloud-native services. And here is, again, a problem of being modern and do everything from the scratch as a cloud-native service, or just being successful from the business perspective. Sooner or later, probably cloud adoption over the world will be on much higher level. But today, we have to live with that cloud is not only solution which customers buy. But at the very beginning, we made two assumptions related to compute platform for cloud native application. We would like to use Lambdas and also containers. Some people can say, okay, why not Lambdas only? We have some experience with that. And again, scale matters. I repeated it several times, but it's still valid, because Lambda seems to be very cheap and affordable. But if you, again, calculate number of requests, size of memory, execution time, and number of our customers, it could be extremely expensive service. And we have to find a balance for the functionalities which are optimal for Lambda and some which will work better in containers. And also related to a cloud native approach and delivering multi-tenant service. In some cases, our multi-tenant services create such workload which is visible externally as a denial of service attack, because we have to interface with different providers related, for example, related to some licenses, to some authentication methods. And in this case, if from one platform there is a stream of requests, like number of them per second, in many cases it could be just blocked because it looks like real denial of service attack. And here we also have very pragmatic approach. It's more evolution, and we try to adopt cloud native and multi-tenancy when it's realistic, when it makes sense, and where it's optimal from both world, cloud and on premises. But we cannot afford to just run revolution and destroy everything what we have and try to go only to cloud native business. And here, our fourth lesson learned. customers and business first. If you are in startup business and you can just experiment, it's great. But if you are running, say, well-established company on the market, you have to take care about your current business. And here is also a dilemma of technical modernity versus stable business. And sometimes you have to agree that it's not most optimal solution. You can do it better, but today market is not ready for that. Also, it's a journey. Whatever you are going to propose and implement today, tomorrow it could be obsolete solution. And for that, it's very important to collaborate with your cloud vendor, whatever this vendor is. Because cloud like AWS, you can see number of features they deploy every even week or day. And the problem is that you can spend number of hours on developing something what AWS just implement as a feature, and this entire effort is no longer required. One of the example is EKS add-ons, which are now, some of them, I know about at least one, which is available as a feature in EKS. You don't have to deploy it manually. And second, related to EKS managed nodes plus spot instances. Those was announced a couple of weeks back. And if you are in touch with your cloud vendor and you can, for example, and you know the roadmap, you follow the roadmap and you can ask also question what they plan, you can avoid a lot of traps where you invest time in something what is no longer required. And also related to support, because my personal experience from, my personal experience is from running application in the cloud is that sometimes you face the issue which you cannot identify or you cannot analyze the root cause without contacting your vendor. Because you just don't have access to all of the features of managed services, because there are a number of logs in the background, number of debugging tools, and you have to ask them what's going on, because in each and every managed service you can face it, and without this support and without this collaboration, you will just be a little bit blind and you cannot go forward. Okay, this was just introduction from my side about our journey and our, let's say, fourth lesson learned. And it was just shared with you. Maybe it will be relevant to your business, to your use case. And now I would like to ask Michał to continue and describe our, maybe not first, but one of our cloud native microservice. And then we will go to Q&A. And we'll be happy to answer your questions. Michał, stage is yours. Thank you.
Thank you very much. So let me simply know if you can see everything in the presentation mode. The first failed. It's better to check that. So what Jacek said before, it was the story that how the Jamf started to work with the cloud. Currently, we are working on cloud very well, and all our services are running just from the AWS. But from time to time, we need to extend our products and deliver some new service here. So there is always the first question, how to deliver our product extension. We have three ways here. First of all, we can simply develop new feature in the application, just extended that. Our key product, Jamf Pro, is a monolith Java application. So theoretically, you can take the code, modify that, develop new part of code, integrate it with the application, and run it as it is running before. So the simple task, it depends on the code complexity here. The second option is to build quite new service and integrate it with the application. In that case, it's possible, of course, to build the your dream application, let's say, which is well integrated with the cloud, use the cloud native services. You can use any cloud feature you wish, and you do not need to care about some technology debt or something like that. But the first two options are always belong from the business perspective. And of course, the business would like to have some new functionalities quite quicker, that it's required to write new code, to integrate, to write to new service, and so on. So sometimes business is trying to find the opportunity to buy some external product and service and integrate it with application. So today I just like to show you such an example just for this point number 3. So buy is easy. Theoretically, from our technical point of view, we just get the product. I know that from the business perspective, it's a complex process and required lots of legal things needs to be done. But finally, we technical team who got the product, and with the question, please integrate it with our infrastructure. So what we can expect? Different hosting that we are using, different technology, different scale, for example. And example of such a service is a patch management. The general patch management in the Jamf is a service which provides the information for our customers about new version of the application titles. So you can imagine that, for example, you have Word or Office package installed on your laptop, and your administrator would like to keep this Office as fresh as it is possible. So if the number of applications is huge, it's very hard for the administrator to track all the patches on the market and decide which one should be installed, which one not. So on the Jamf Pro, you can see and subscribe some information about patches, and we are providing for you the information that the new patch has been released by the vendor, and you can decide to force the installation on your station or not. There are two kinds of patch services. First one is a global one. You can where about the freshness of the patches. Jamf is care about the freshness of the patches. So our team is responsible for delivering you information about the new version of the application, and you do not need to care about that. Just simply subscribe the specific software title, and you can got notification, and some workflows in the Jamf Pro can be triggered if the new version of the application has been released by vendor. The other part of the patch management is the patch management for the Jamf Pro admins. So theoretically, the Jamf Pro admins can expect and can create some separate own patches. For example, if you are a big company, it's worth to get. If you are a big company, you can get some own software titles, not publicly available, which are private, written especially for you, and you would like to manage it as a public one. So you can have some external service which can do that for you. And from the Jamf Pro perspective, it looks like that there is a Jamf Pro, that there is a global Jamf patch service available, where the titles are managed by the Jamf team, and there is possible to attach the external information about patches from the custom services. And one of that custom services was Kinobi. So generally, our customers had possibility to subscribe Kinobi software, create their own account, and manage own patches there, and attach it to the Jamf Pro. So from the perspective of the Jamf Pro, if the new application title appears in the some public titles or in the private one, both information were treated the same, and admins have possibility to create the identical workflows on top of that. So Couple of months ago, Jamf just acquired Mondada. Mondada was an owner of the Kinobi software, and Kinobi, as I said, is a patch management service for Jamf Pro. So generally, from the Jamf perspective, we've got the new service or new product we would like to somehow integrate with our services and make it ready as other Jamf Pro products to be visible for our customers. What kind of challenges we met during such a integration? First of all, scale. Mondada has a couple of dozen of customers, and it was a very small company, only 5-person company. So comparing to the Jamf with the more than 1,000 people on the board and a couple of dozens of hundreds of customers, thousands of customers, it's a really huge difference. So the software provided by the Mondada were never tested for such a scale. Hosting. So as you know, Jamf using AWS as a primary platform. So we are hosting all our products in AWS. Mondada hosted their products in Azure. So, the totally different platforms. The other part is languages. Kinobi is the PHP application, Jamf Pro is a Java. So again, we don't have the solid bridge to connect both applications. And the final problem is the deployment model, where the Kinobi was each customer of the Kinobi have separate instance per customer of all this whole stack of the Kinobi. So let's start from the global patches. The global patches is a service managed by Jamf. So we would like to somehow use the new technology, which is somehow more flexible, provide more information for our Jamf Pro users in our service. Jamf had such a service which were responsible for patch information delivery, but it was not so rich as a Kinobi one. So we decided that the Kinobi can be our source of truth for the information of patches. But we need to scale it up, ensure that all our customers can hit it without problems. So it's a kind of challenge. So we decided to use a couple of AWS components here. First of all, EKS, as Jacek said, we are adopting that. Before so to be able to scale this solution according to the traffic, so we have the EKS, we can have some pods auto-scaling here. On the other side of this backend, we have the Aurora. So with the Aurora, the scalability options are not so good because we need to create some instance and we can scale it up or down by only restarting that. So some issues with the service continuity can be visible here if we would like to turn off the Aurora, change the site, turn on it again, and doing such a thing couple of days can be noticed by our customers here. That's I think that most problematic service in this architecture. The other one is an API gateway, and in my opinion, is the key components here because thanks to that we've got the lots of flexibility here. Why API gateway? So the first of all, we use the caching options here. On the graph, you can see here the number of requests on our infrastructure. I've put that only to show you the scale of that. So generally speaking, we have the flat traffic, not lots of additional requests, not some crazy mountains here somehow, but you can see that there are some peaks here. Theoretically, they are very tiny, so it shouldn't be a case theoretically, but the peaks are very important from the Jamf Pro perspective. That's the points in time where the information about the new patch has been delivered. And then all our customers try to get information about the details of such a patch. So we need to be ready to scale infrastructure. You see here almost 2 times more to handle only these small spikes. The height of the spike depends on the popularity of the patch requested by the Jamf Pro. So here are some patches with the small, not so popular, but here probably some new Office or Adobe software has been released by the vendors, so lots of our customers use that. So it's huge additional traffic here. So theoretically, the spikes are very not so very tiny. So it's very hard to scale infrastructure to handle that rapidly, because it takes 10 to 15 minutes. So it's hard to spin up additional servers, populate it with the code, and be ready for that. And we can expect that after when we start the new server, the spike will be finished, and Jamf Pro instances will get the wrong information. But we can handle everything in cache in the API gateway. Thanks to caching, we don't have that spikes on our infrastructure. This is fully handled by API gateway, and we do not have any additional traffic here, because on the first request for such specific patch information goes to our backend, and all the other traffic is handled directly from the API gateway. That's the brilliant, because we do not need to care anymore about the really rapid scaling and hard and things what is hard to predict, because the business team is working independently on us and is providing such patches, and we are not informed that, for example, new titles has been released. So thanks to this, we've got lots of flexibility about the load here. The other very useful option here is that we can separate each endpoint, which is handled somehow by API gateway. And if we observe that it's worth to rewrite some part of our application and put it to lambdas, for example, because of something, because the endpoint is not very often used, and it's not causing quite a huge load, but can be unpredictable in the number of requests, for example, it's worth to use Lambda. Thanks to the API gateway, we still stay with the same, let's say, manifesto for our instances. So the endpoints are still the same, but we can simply replace only the backends here. So, finishing this topic, API gateway helped us to solve the issues with the unpredictable traffic here, with the very high spikes, but with the very short ones. And thanks to this, our customers do not face any problems with the access availability of our service, even we have the quite big load here. So private patch management is another part we have here. As I said, the Kinobi software was delivered to some customers. So currently, we probably can have some similar service for our customer on the top of the Kinobi. So taking this application, we had a couple of options. First of one, pack simple application to the container, run containers in the AKS, run separate pods per customer. It's the easiest way. As I said on the beginning, the applications was written that each customer's got own instance of the software. So it's natural way that probably we can go with this way if we would like to adopt this application and run it our cluster in our standard and use somehow EKS here. We can create separate DB schemas per customer. So for isolation of data, for isolation of the application. That looks great. But as Jacek said, Jamf have more than 40,000 customers. So theoretically, each of our customer can want to use this software. So if we assume that only 40,000 potential customers can start to use that software, application required at least 125 megabytes of RAM. So if we simply multiply that, we can fast realize that for such an approach, we require of 6 terabytes of RAM. To have 6 terabytes of RAM, we need around 100 R5 2x large EC2 instances. Again, multiplying that by the hour cost, by the number of instances, by the hours per month, we've got $45,000 per month only for a small service. It's not a really huge and complex application, it's a rather small service. So what Jacek said, scale always matter, and we need to worry about that. It's the easiest way, theoretically starting this way, we can finish all the migration in week, and theoretically we will be ready with the work, but I don't know what the business can say about potential cost as such a small service. So the second option is requires some application modification, because in that case, we assume that it's possible, for example, to switch the application context and allow users to decide about the context depending on the logged user. So we don't have the separate containers per each customers, but we have some more generic containers with the application which can handle many users depend on the context. Again, we can, of course, pack this to the container, run only a couple of instances of the same application in the pods in that case, but we still need to have separate DB schemas for each customer. Option 2 is more demanding because requires some application changes. It required to manage thousands of DB schemas if the customers would like to use that. But we've got a small memory footprints because we do not need to worry about the separate containers. Thanks to this, required only few worker nodes on the backend to handle all the traffic and can be easily scaled. Option 3, so we can create fully multi-tenant application with the multi-tenant DB schema, with the application which is able to decide which tenant to use and use some discriminator here. And of course, we would like to run everything on EKS. Options 3 was the most complex one and most time-consuming because it required deep application changes. It simplified the schema management, but still the benefits from simplify of the schema management do not cover the complexity of required changes in the application. So the option 2 looks quite optimal from that perspective, and using such options, small changes in the application, putting everything in some EKS and using the power of the cloud services, we are able to provide the service which is not really cloud native here, but is using the cloud native services to manage them. For example, here is additional layer I do not mentioned before. It's on the top of that slide you can see the application layer, but on the bottom there is an additional layer we create in the AWS. It's a typical cloud native layer responsible for the tenant management. Thanks to this, we can create the additional tenants, create the schemas in the database, inform everything about the success or not of tenant creation. So thanks to these cloud services, we were able to provide the functionalities quite quick. But it is, of course, not the end. There's some middle of the way we would like to walk. So our further plans, of course, we do not would like to stay with the some kind of monolithic app running in the container, but probably we again use the API gateway, separate the user interface of the application from the backend. We can, thanks to this and thanks to use of API gateway, we can try to again split the application to the services, rewrite some parts of the application, not all of them, and run it as a Lambda. Some of the application can still running in EKS. The other parts can run in the other cloud services as well. We can, finally decide that some part of our service is not required still the Aurora database, but can use some DynamoDB to store some additional information. Switching this application to and splitting the user interface from backend using API gateway, we can get we can make the another step. We can try to integrate this service functionality directly with the, for example, Jamf Pro user interface. So thanks to this, we can extend the functionality of the application, and we can have real cloud native application. But as I said, we are somewhere in the middle of that. Currently, we still are using some parts of the monolithic app, which is managed by cloud, which is somehow adopted to the cloud, but it is choice we did before, and this is this pragmatic way and programmatic approach mentioned before by Jacek, that it's better to do less sometimes, build some smaller adoption and smaller integration with the cloud by provide the business functionality quicker. So thank you very much. That's all from my side.
Okay, thank you very much, guys. I don't see any questions in the chat. Maybe someone has some questions. If no, I have some questions, because Jacek was talking about the problem with deployments at scale. I mean that when you switch from the plain EC2 instances to the Kubernetes, for example, the EKS, it is quite obvious that you had to change the deployment process. But what are you using to deploy applications? I mean, are you using Terraform, CloudFormation, and some type of third-party tool, or how does it look like in your case?
Okay, don't want to disclose too much, but in most of the cases, we just rely on own tools, and we use in the backend CloudFormation, Terraform. It really depends, and also some, let's say, deployment and CI/CD tools for that. But finally, we have own orchestration level to deploy our application. Because also it's related to entire life cycle of the customer, because you have to plan the process when customer is onboarded. Some of the customers are migrated from on-premises to the cloud, and finally they are terminated, and we have to terminate the contract, instance, or tenant, and also clean the data. And for this purpose, we have own tooling behind the scene.
Okay, thanks. is quite interesting because writing such tool has also some challenges.
Yeah, I think that it's even bigger challenge than just configuring EKS. Maybe the colleagues from this team will be happy to share their experience with that. I will ask them because it's definitely interesting because this tool now is really cloud native, and maybe it's interesting to share what is there behind the scene.
Okay, you were also talking about the importance of decision making when it comes to the choosing the right service for concrete case, and I'm curious about some if you had some major issues because your wrong decision in the past. I mean, when you have chosen the wrong service and you had some issues with stability of or of billing because of the wrong choice.
Yeah, because I'm the history of this company is quite long, and I heard from my colleagues. One of the challenges was that in the first iteration, people wanted to use just database installed on EC2. This was problematic, and after migration to RDS Aurora, let's say the stability of this database subsystem was much higher and more reliable, and this was a very good decision. Even it's more there are more costs related to this naturally, and other, we still struggle with the sizing because even we have we perfectly size for particular environment, and then our customers expect new functionality, new feature, and new version is deployed, and we see different behavior of the entire fleet of the servers because colleagues report, okay, it looks like this new functionality causes more memory consumption, yes, or more CPU or whatever, and this needs to be somehow observed. And also, thanks to migration to EKS, I hope that we'll be able to react more agile on that changes.
Okay, thank you very much for the answers. Okay, I don't see any questions in the chat, so thank you very much, guys. It's a pleasure to hear the presentation. And I think it's time for Darko and his presentation. I see that Darko is ready. So the stage is yours, Darko. Oh, you are muted.
Hardware mute buttons are the best and the worst thing in the world. I love that I can mute myself, but I forget that it's muted. So yeah, thank you very much. And thank you everybody else for having me here. And thank you to Jacek and Michal for the lovely presentation. Before we start, because it's 7 p.m., time for a beer. Cheers. One of the things I miss about in-person meetups is the chance that I have to drink beer with you. So I have to drink beer alone, but kind of with you, it's good enough. So cheers, or I don't even know how to say it in Polish. Wait, let me try to remember. How do you say cheers in Polish? I guess na zdrowie or something like that in that sentence. But yeah, you'll let me know. Okay, time to share a screen. Share. Boom, 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 like that. Can you just pull up my screen? Thank you very much. See, this is cooperation. So, na zdrowie. Okay, there you go. See, I was correct. So I see Christoph is drinking wine with me, and yeah, thank you. I'm gonna drink my almost warm beer, but yeah, what can you do? It's beer. So, na zdrowie, everybody here, and thank you very much for having me. Today we're gonna be talking about testing code. My name is Darko, and we're going to talk about a bunch of different things. I'm going to try to make this as interactive. We're going to do some demos. We're going to talk about the fun things. But let me get started first. Long time ago, so I've heard Jacek and Michal mention that they used to ship software in boxes. Yeah, that was the case. 35 years ago, you got software like this. You got it in a cartridge, or maybe you got it in a box. The problem with that was that once you decide to ship software, and if you have bugs in that software, it was very difficult to, well, fix it in real time. You know, on a Nintendo, there was basically no way to fix it. People were stuck with bugs. If you would buy your MS-DOS or Windows, you can maybe fix it by sending out a patch with a diskette. It kind of works. We moved on into the internet world, and even when people were buying software on disks, you could still kind of update that software over the internet, if there was a problem. But in today's world, in the world of SaaS, in the world of things as a service, where you can literally push changes to your software every 5 minutes and it will be fine, right? We have become complacent with the fact of like, well, how bad can it be? I'm gonna just push this to production. If it fails, I'm gonna fix it, and that's a good mindset because it helps you experiment things, but we still need to be careful, right? So we need to talk about, why do we test code, right? Why is the reason we test code? Yeah, of course, you're an amazing developer. You just know all the things about a given programming language. You are very, very intimate with your workload. You know all the ins and outs. You built it from scratch. But in the wise words of older me, Werner Vogels has said, everything fails all the time. So no matter how amazing you think you are, you just wonderful in coding, it may fail. It's not your fault. It's not the fault of a system. It's just the way it is. It's called entropy. Things just go bad from time to time. So the more you are familiar with a system, the more relaxed you are, the more likely you are to introduce errors. So we need to test because of that. But where do we test the code? Where should the code be tested? In your editor? In your pipeline? In production? Everywhere. You should test your code everywhere. Wherever you can, your code should be tested in one way or another, right? It's also very important to detect these problems as soon as possible. This is why I say where. You may have amazing pre-flight checks on your production deployments. You may have like all the things there, checking if the application is good, will it work fine before going to production. But remember this, it's not the same if you fail on production, staging, development, or in your text editor. It costs much more to fail in production than it costs to fail in your build stage. So catching the errors early on make your life better, make your colleagues' lives better, and also gives you more time to enjoy warm beer. So the final question is, what do we test? What is this thing? Yes, code. Yeah, absolutely. But how? What? Well, this is what today is about. This is what today we will be talking about. What do you need to test? Where do you test it? And how do you test it? A little caveat here. I'm not going to cover all the testing strategies in the world. We only have half an hour, right? So I'm going to cover some, but I hopefully will light the fire for you to research more on some additional testing methodologies and testing practices out there so you can make your workload safer once it's deployed. Speaking of safer once it's deployed, you may be wondering, and I was introduced here for a moment, but who is this bald person and why is he yelling at the camera and drinking a beer at Tuesday at 7 p.m.? Well, my name is Darko Mesaros. I'm a developer advocate. I love talking to developers. I love talking to engineers. I love hearing your feedback on how AWS is doing. I love hearing your feedback on how you do things. I love teaching people to do better things. I love taking a topic, diving into it, distilling it, and trying to spread my experience and the knowledge I've learned to you. I also happen to work for AWS, and I also happen to live in Berlin. So I'm relatively close to Poland. I've been to Poland once. Well, if you count the Warsaw airport, that's once. But never been in Poland. So hopefully once this entire play goes away, I got a chance to meet you all actually in person and have some beer and pierogies or something like that. If you want more of this loveliness here, check out the social medias thing. I do some streaming, I do some YouTube, and of course Twitter and social LinkedIn's. So let's get started. Also, feel free to ask me questions during the chat. I actually see the questions as I present this. So if you have a question about what is this person saying, feel free to rub it in. I'm happy to answer it immediately, or we can leave it for the end. So let's start. Let's start with the first place where you can test. Yes, the first tests are inside of your editor and in your version control. Think about it. Think about what is the first test in your text editor, in your IDE. Does it compile? Of course, I know not all languages compile, but your IDEs will be the first things that catch problems. You may have some advanced things like, for example, you may have the AWS Toolkit installed on your web store, and the AWS Toolkit can test your application, your Lambda functions directly in the text editor, right, in the IDE. So in this example, you see, number one, I have a hello function. I have a function defined in AWS serverless application model. Excellent. I click the little green button next to the one. Number two, you see it's running a local hello world function. What does this mean? It actually triggers that Lambda function locally on my workstation using Docker. And three, I see the output of that Lambda function being executed locally. Excellent. A very fast, efficient way to check does your code work in your editor, right? Especially when working with Lambda functions, and Lambda functions can be amazing, but they can also be very unwieldy. A lot of things kind of are abstract, and we want to make sure that we kind of at least try things locally. And with this, you can basically try it locally on an airplane because you can run your Lambda functions on your inside of a container locally. So great way to catch errors early, right? And this is all thanks to AWS SAM, but in this case, the tight integration with the AWS Toolkit for all of these things. So AWS Toolkit is just a little plugin for your IntelliJs, for your Eclipses, for your Visual Studios, where you have the ability to not just run your SAM applications, but do a lot of other things like get the logs from CloudWatch, or get a CloudFormation template down, or even do something with state functions. Not state functions, with state machines. So yeah, that's the first thing, right? Besides those squiggly lines you see on your text editor telling you this is a wrong thing to actually executing the Lambda function internally, that's a really fast way to fail. And how much does this cost you to fail? Nothing. It's on your laptop. It's almost nothing. You click the button, you see it didn't run, fine. No money spent, nothing deployed. You didn't have to even wait for it. So what's the next step? What is the next step? What's the next step after our code compiles successfully? Our code looks fine. It just works amazingly in my editor. It works on my machine. Hey, we're using Docker, so it works on my machine. That's fine. What's the next step? It's your code repository. This is where you have to go ahead and ask your colleagues saying, hey, I've just committed some code. Can you please go ahead and have a look? Pull requests are amazing testing utilities. They're not automatic by any means. There are ways to make them automatic with, for example, Code Guru, but most of the time they're manual. And you commit your code, push it to a repository, make a pull request, and somebody has to look at it. Now, it's cheap, but you need to take 10 minutes of somebody's time to look through your code, because a lot of the time you may think that this is perfect, right? Nobody can write better code than me, but you notice things. Somebody will come and say, what about this, right? It's the good old rubber ducky method. When you explain things to somebody, you find your problems. So this is that next step. The next step is your version controls, your GitHubs, your code commits, your Bitbuckets, and also the rubber ducky method, that is the pull requests and code reviews by our colleagues. And one story I have is that when I've started at AWS almost 5 years ago, I had an idea to improve a service on AWS, like to make it better. And I reached out to the service team, and I asked them, hey, can you implement this feature there? And I had it already prepared, like, this is what you just need to implement. And they're like, okay, can you commit that code to our repository? Okay, I did, and I thought it was amazing. But then I came to a code review, and somebody just asked me, what is this here? Why did you put that? And then, once you can answer all the whys, you should be fine. So why am I talking about GitHub and code commit and rubber duckies and your IDEs? Start early, test early. There's no too early of a time to start testing your code. If you test early, you will fail early, because then gives you the ability to actually just try out things. They call throwing stuff at the wall and see what some of it will stick, right? This is the same thing. You can try things out to see if they work, and if it fails locally, or you just bothered somebody for 10 minutes. So it's not very expensive. But in this case, you can use your AWS toolkits, you can use your SAMs to run things locally, but also your version controls, your pull requests, your code reviews, and if you want to take it a step further, doing something more, you can use something like Amazon Code Guru, which uses the power of machine learning to actually identify potential problems in your pull requests and also profiles your code to make it better. But we're not going to talk about Code Guru right now. Okay, we talked about starting early, testing early, all of these things. What is the next step? Next step from this on, and actually there's a question from Dominic. Dominic asks, do you have any advice how to test Lambda Edge? Is it possible to test it somehow locally, or better use an A/B canary testing inside a Lambda function? I don't have a good answer for that. To be honest, I haven't worked a lot with Lambda at Edge. Ideally, Lambda at Edge is just it's a Lambda function running somewhere close to you. You can test the code in a normal Lambda function unless it has to interact certain things. So I would love to take this question later on and try to find the answer for you in this case, because I have not been working with this, to be honest. So moving on from our text editors and code repositories, what is the next step? And this is when somebody says testing, this is what they mean. Like when you say, oh, testing code, of course they're talking about unit testing and beyond. And let's talk about unit testing and beyond. How can we do unit testing on AWS, right? So, well, you can of course do your unit testing within your text editor like before. I actually didn't show that, but you can, within your local workstation, local work environment, you can run unit tests. That's what a lot of people do. But usually running unit tests at scale involves a pipeline, right? So we need to push our code somewhere, and that code needs to go somewhere else to go into what they call a CI/CD pipeline, right? And CI/CD pipeline is an orchestration pipeline, a framework that gets your code from one part to the other, to production, right? And within this pipeline, this is exactly where we run all of these codes, all of these tests and whatnot. So let's actually start with a bunch of things. Let me answer the age-old question, what are unit tests? Now, I'm not a professional developer, please understand that. I know a lot of you are. So when you approach a unit test, a lot of people have their different opinions what a unit test is, or what's the scope of a unit test. So according to the information I have and the experience I've gathered over the years, a unit test is exactly that. Think of it this way. It's like playing inside. So you don't get to go outside to play with the other kids. You can stay in your room and play with your own toys. This means you're testing just a single thing, a single unit of stuff, a thing that you pass some data in. It's a black box. You pass something inside, something else comes out. That's a unit test. It's just a single unit. You're testing, is it outputting what I expect? Is this little unit outputting my hello world? Is this thing, can it process the data in the way I want it to process? There are no external dependencies. It's only the unit. If if you have an external dependency, like a data or an API call being made, or a read from a database, you mock it. And by mocking, I mean you basically fake those things. You create local data sets, which is just like a JSON object being passed or something. You imitate a database call or something or the other, all locally, no external things. It just runs within its own bubble, just so you see that it works. And in most cases, when we talk about test-driven development, this is where it starts. You write a unit test. You write a unit. This is a unit test. You write something that you set an expectation. You set an expectation that something will do something. And then according to Ken Beck, the way you do test-driven development is you write this test, and then you write the code to pass the test. Simple as that. So, and this is an example of a test I have. So if you see here, this is a unit test for my Lambda function. And my Lambda function in this case is just, I'm importing a Lambda handler from here, right? Nothing too fancy. But what I'm doing here is actually I am using Jest. In this case, Jest is a framework for testing JavaScript, and I'm setting some expectations. I'm telling it, hey, I expect the status code to be 200, and also I'm expecting the result body to be a query followed by some arbitrary query string that comes in. And when I run this test will basically imitate an API gateway proxy event because it uses this Lambda module from our SDK. It imitates an API gateway proxy event. It passes just a column 1 as a query parameter, and it just verifies does it get the same back. Simple as that. No external things. It all runs within the single JavaScript piece of code, all that. So to recap, unit testing. Does your code do a thing? That's it, right? Can it process the data the way you want it to? There are no external dependencies. Remember, it's playing inside of your home. It's very much self-contained. Something comes in, something comes out, and you check if that thing that comes out is the thing you expect. And finally, it's testing just a single unit. Don't go ahead and test your entire application. Do not create a unit test that will create an entire user and everything behind it. So that's the point here, right? So just a little thing. Just do like this. It's just returning a 200 in a query. Of course, that's my entire application in this case. But if my application was more complex, it would just be doing a single thing. Okay, so where is this in your text editor, Darko? Like, do you do this in your this web store? Well, yeah, but also if we're talking pipelines, we're talking code build. So if you remember the pipeline thing, on one of the build phases, we can use code build. And this is an example how you run code build. Code build is a service that, well, builds code, but in essence, it takes the code, takes the artifact from a repository and does something with it. And what it does in my case, it's just running npm run test. So I'm not sure if you can see this here, but right now here, npm run test. That's it. An npm run test basically executes a unit test I told it to. It runs a test, and if it's successful, it passes. And then code build says, hey, it's good. The unit test has passed. You can continue down the pipeline. Speaking of the pipeline, this is where unit tests sit, right? The big old build phase, even though not everything is compiled these days. But it also sits, inside of your text editor or your IDE, because it's again really fast to do it. Okay, let's move on down the pipeline. Let's move on down to something called integration tests. And for me, it's easy to talk about unit tests because unit tests are kind of self-evident, and it's like, oh, we have a service that can help you do unit tests. But integration tests are something bigger, right? So what are integration tests? Actually, let me show you an integration test. Well, gee, Darko, this looks very much similar like the one before, but it's not the same thing. So it's different. An integration test, as you can see here, what I'm doing here, I'm using Axios. Axios is just a module that will run an HTTP GET request to a URL. Now, what is this URL? This URL is my application. it's my application actually running somewhere. So all of a sudden, we're introducing something called, wait, this is not self-contained. This is running somewhere else. Yes, it's localhost, but it's running somewhere else. It's a dependency. Yes. So it runs this, it gets a response, and then again, like before, it has expectations. It expects the status to be 200, and it expects the query to return the query string. So how do we make this work? What is this thing? What is this thing that it's listening to? Where is it reaching to? Aha. This is where, when you're using serverless applications, or when you're using SAM in this case, you can use SAM, serverless application model. So what I'm doing here, I'm using SAM local within my integration test to deploy my Lambda function, my Lambda application locally in a container. So when running my thing there, my integration test, it will actually execute the Lambda function like this in a Docker using SAM local, and then it will use Axios to actually try to connect to it and get something back. And again, this looks quite similar to the unit test, right? Doesn't it? We also have expectations. We're querying something, but in this case, we're actually making a call to something external. It's not external. It's running on the same box as everything else here, but it is a different thing. We're calling an actual API. So, and this is a successful integration test. Again, running npm run integration test, or whatever you call it, it will run my Docker container with my Lambda function, completely start it up. So it runs with all the API gateway emulation, all those things, and it just calls that API. So why are integration tests different than unit tests? In this case, it's not the best of examples, because I'm actually showing you the same kind of test because my application is so small. But think of it this way. How does your code play with the rest? It's not playing inside. It's going on the playground and playing with the other little APIs out there. So you actually get the chance to speak to other units, to other pieces of code, to other functionality of your applications. You actually get to test the entire application to see, does it all fit and work together? You are connecting to external dependencies. You are connecting to a database. You are connecting to an external API. You want to make sure that this thing can actually run in a fully set up pre-production environment. Also, you want to make sure that your entire workflow is doing. Now, the example I showed here is very simple and plain. It's a hello world application, right? But if there was an application that would create a user, for example, an integration test would do all the tests. It would actually go ahead and create that user by calling multiple different APIs and elements of your application and see if they work. And it will expect a specific outcome. In this case, a user has been created. Now, it will query external systems. It will query databases. It will do all of those things. But it is very important to try to run it in a pre-production environment. Because if you run an integration test on your workstation, it doesn't prove a thing. Yeah, of course, it can tell you modules work together. But what about networking? What about all the other things that can be problematic? So very important to run it in a good setup. How did I run my integration test? Same as before, I use code build. Now, of course, there's a lot of things out there, but in my case, I just use code build. Code build will basically provision this little container with the Lambda function on itself, and it will run the npm command there. Not the ideal example, but it's for this such a small thing, this works really good. If you want to take it a step further and do something at scale, well, there's a lot of integration testing out there. You have JMeters, you have APMs, you have Seleniums, but you also have Lambda functions. I've seen people actually use Lambda functions as their entire integration suite. You can have your pipeline trigger a bunch of different Lambda functions, do a bunch of different things just to make sure that every little thing out there works. So it's not just code build, it's all of these things combined. And like before, where do these tests exist? Where do they live? They live, again, on your pipeline within the tests phase. Now, I want you to pay attention here. There's a lot of different tests you can do. It's not just integration. In these little boxes here, I have health checks, I have functional tests, I have integration tests, I have bakes times, I have load tests, user acceptance testing. All of those different things are part of your testing. In this case, I'm talking about exclusively about integration tests, but you can expand this to be quite different. And the alpha, beta, and gamma, these are environments, right? These are things that are supposed to replicate your production. So gamma is the most like production. It's at the same scale or almost the same scale as production. Beta is smaller. It's maybe like the same thing as you have in production, but on a single server. And alpha is just a limited example of what you may have in production. So these things are kind of connected to each other in the difference of sizes, because you want to make sure to catch different things at different times. For example, load tests. You wouldn't run load tests on alpha because alpha doesn't represent the full production system. So these are kind of things. But integration tests, this is where they live. This is where they should be doing. I've been talking too much. Let me grab a beer. Oh, a warm beer. Okay, finally, testing in production. What? Yes, you test in production. Wait. Aren't we done once our code reaches production? Aren't we just... It's deployed successfully. I have it out there. No alarms have been triggered. It worked on all the different stages. It worked on my laptop. It worked on the unit test. It worked on the integration test. Why should I care about my code being in production? It's good now. Remember, everything fails all the time. So no matter how good everything else has succeeded in your pipeline, you have no idea how customers can ruin your applications. You may have amazing quality assurance folks, your QA team, that will test all of those things. But customers can be very inventive in the way they can break things. So we need to keep on testing. We need to keep on seeing, does our application do what we want? How do we do that? Observability, right? We gather metrics, we do logging, and we do tracing. What does this mean? Let's talk about metrics first. In metrics, your code, you may have made a new change to your code. You may have implemented a new plugin or a new unit or something. And your code works perfectly. It compiles excellently. All the unit tests pass, all the load tests pass, all the integration end-to-end, everything is just great. But all of a sudden, when you reach production, the code still works. No, that's all fine. But let's say your user creation took 12 milliseconds. And with your code change, all of a sudden it takes 34 milliseconds. That's a problem. That's bad. That's almost 3 times as much. But your code isn't bad. Your code it works, right? So this is important. When we release our code, even on the load testing part in Gamma, we need to keep on collecting information. We need to keep on gathering. Does the code change actually impact certain things? Are we measuring things? Are we seeing, is there a bigger latency now? Is there a longer delay in converting the PDF files or whatnot? So that's very important. Logging, of course, logs are important. I can talk for days about logs and how they should be implemented and what you should do. But having the ability to see things as they happen, to see errors being thrown, exceptions. Are you getting more 5xx in this case? Are you getting some weird things in your error logs on non-UTF-8 characters? So it's important to log stuff, what you do. And finally, for those little itty-bitty nitty things, like detecting a bottleneck or finding maybe 2 different functions don't work so well together, tracing. Tracing gives you the ability to have this wonderful map of different services, of different Lambda functions, of different units talking to each other and getting your graph where you have different connections of different things and how long they take. Amazing things. So how do you do all of those things? Well, there's a bunch of things on AWS that you can do, from your logs to your traces to the metrics. And speaking of services that cover this, well, we have good old CloudWatch logs, and X-Ray, right? So these services, once you tightly integrate them with your application, give you the ability to actually see things, see how things are happening, and as they're happening, you can react. If something went bad, again, Get that 34 millisecond metric out there. And if you notice a spike all of a sudden, maybe you should roll back. So this is very important. Testing is never done, right? You don't stop testing your code. Even once it reaches production, you actually keep on testing. So make sure to monitor for outcomes. One of the things is we as engineers love to, I'm going to see how many requests per second I have or how much CPU or memory utilization I do. But monitor for outcomes. Have a metric that looks for how many new orders are being created or how many new users are being created. If there's an anomaly in that, if all of a sudden I'm not getting any orders, something may be wrong. So keep on monitoring for business outcomes. And this is where you talk to your business people. Ask them, so what is the business outcome of this? What can I measure here that if it goes bad, something's wrong? So very good. Of course, one thing is to test your code constantly, and the other thing is not able to do anything about it. So make sure to have a proper rollback procedure. If you deploy code to production, don't copy it manually. No, have a proper deployment procedure. And then if something really goes bad, have the ability to roll back. If you're looking for a thing on AWS, CodeDeploy does that. CodeDeploy is just great when it comes to rolling back bad code. And of course, look at metrics. Metrics can tell you a lot of how things look and feel. Okay, let me actually show you some code right now. I have a little demo-ish thing prepared here, which I'm going to try to show. It takes a longer time, so I'm just going to show you around some code and how I set it all up. Not all of this is just me talking on my behind. So let me stop the screen share like this. And wait, can you please just add the other screen share? Thank you. No, that, sorry. Let me share the screen, one moment. Entire screen. This is the magic happening now. Wait, perfect. Aha. Good. So I'm gonna actually show to you how I've deployed things that I've done. So I've actually created a bunch of things here. I've created a pipeline, I've created my serverless application, and I've created a whole deployment procedure for that. So looking into this, let's go first into my pipeline. This is it. I have my pipeline here that takes my code from a repository and takes it in the source phase. This is where it just picks up the code from code commit. On the build phase, this is where it does all the unit tests. I'll show you how the unit tests are done in a second, but this is where the unit test part of it does. This is just to make sure does the one thing work. Then if it works, it goes on to the integration test. This is where it launches this Docker container with my Lambda function and it calls things on it just to make sure that all that works. And then finally, it deploys my code. Now the deploy code here works differently. I'm deploying a SAM application. So what I'm actually doing is I'm actually running a SAM deploy in this. It's also using code build. It's running a SAM deploy to deploy my application somewhere out there. But what's smart about SAM deploy is that I have enabled something called canary deployments. I have not talked to you about what canary deployments are, but canary deployments are these things where you deploy the code to production, keep on listening to problems, and if it fails, roll back. So let me show you. First of all, let me show you some code. So this is my super simple Lambda application. Nothing special. It's just a hello world thing saying, it doesn't say hello world. It basically takes the query. And actually, let me show you how it works. So I'm going to run something here. I have a little alias called Polska. This is going to run a little curl application to my endpoint and just going to return basically the query and is Cześć Polska. So that's what my application does. Very, very amazing. I'm just going to generate some traffic so I can show you this later on. So this entire application is just super simple, saying single Lambda function application, nothing too complex. Let's make a change to it. Let me try to break this application intentionally. I have a sleep thing here. I have a sleep function or a sleep method here. I'm going to increase it to 10,000 milliseconds. Saving that. Perfect. And then let's actually push this code to my repository. I found out about a great tool recently, so I'm going to share this with you. So I've heard about LazyGit. LazyGit is a lovely command line utility that's a command interface. It gives you a lovely graphics interface of your Git commit. So you can see here, I've made a little change to my application. I say, yeah, that's fine. Let me commit this. Yes, commit. This must work for sure. And then push. I'm pushing this change now to my Git repository. And if I go back to my pipeline, in a second or so, I will see that this code is actually kicking off and being deployed. So it actually automatically detects based on a webhook or a CloudWatch event, I believe in this case, that something has happened. So, okay, it was faster than us. So it already completed and it's now in the build phase. So if we go to the build phase, we will see the following. We will see a big log output of the code build container showing all those things. Now it takes a minute or so for this to start up because code build is basically a Docker container running somewhere in the midst of the cloud, and it will do all of these things for you. So while that is happening, I just want to go back to the code and show you how my unit test looks. So going back to my code here, and let me close this off and open up unit test. So this is that unit test. It's complaining here. Don't focus on that because I don't have the Jest thing installed right now. But it's basically running this Jest framework, and it's running the expect result to equal 200, and it's expecting the body to return the query string. So this is what it will be executing. So, and if I open up package JSON, this is where I define how to do testing in JavaScript. The test is basically just running a test -- config, and then the running the local test in this case. So going back to this, we can see that it's done all the things. It has installed npm and run npm run test, perfect, and it has succeeded. Excellent. So we see that the test has passed, and if I go back to my pipeline, we will see that it's now running the integration test. Now the integration test will take a bit longer. Mind you, last time I did this live, it failed. And I'm blaming Docker Hub for that. So if this succeeds right now, because Docker Hub throttled me for some reason, I might have tried too much. So what it does here, it actually launches this Lambda function locally. So if I go back to here and open up, I don't know, integration test. Here's my integration test. Again, it will query this thing here, right? It will use Axios to connect to this thing. But one great thing about this entire thing is that it will actually run SAM local first, right? It will run SAM local. It will execute SAM local start the API, and then it will go ahead and query that API. And if it gets the proper results, if it's a 200, and if it gets the query back, it will consider this a successful integration test. Okay, let's see what's happening here. Container is fine. Installing SAM CLI, perfect. I think this works okay. It's not finding the image. So now it should download the image from Docker, and this is where it failed last time. So, okay, I think it's fine. It's okay. It has a local image. That's good. Once this is done, it will basically we will have this little API running locally, and then we will have this integration test basically query this thing. Perfect. So hello test, it has passed. Excellent. So this works. So now what has happened in this case, it will pass my integration test and it's on to the deploy. The deploy in this case, because it's running SAM deploy, it's basically just updating a CloudFormation stack. So in a second or so, we will see, actually, no, because it's deployed already, we will see it in code deploy. So if I go to code deploy, because I'm using Canary deployments, I will be seeing a deployment right now. There's a deployment progress in here. As you can see, where is it? This one. No, go back, please. Did I say code deploy? I clicked on code build. Code deploy. There is a deployment right now, hopefully. Come on, I need to kick off. You need to kick off the deploy, please. It will take a moment or so because it starts the container once again and all that stuff. So if we look at the code thing there, and if we go back to CloudFormation, we should be seeing an update in the stack happening right now. We can see update is in progress is happening. Okay, going back to code deploy and refreshing this thing here, we should slowly be seeing another deployment in progress. Perfect. So this is a deployment in progress. As you can see, it has shifted only 10% of the traffic to the new version. And now what is happening right now, because I am making traffic in this case, I am causing traffic constantly with my little script here, it will measure, it will actually monitor for an alarm. And I have an alarm set up in CloudWatch. So if I go to CloudWatch, this alarm is set up here to trigger if my Lambda function execution duration is longer than 4 seconds. And I will see it's being in OK. It's currently OK because it doesn't have a lot of information. So as long as if it's longer than 3 seconds, 3000 milliseconds, it's fine. But what's happening now, every 10% of the queries I get the new version, and the new version is broken, and it lasts 10,000 milliseconds. So hopefully this little metric will notice that thing. It will see, oh, the alarm has been triggered, and if this alarm is triggered, the deployment will fail. So this will actually say, okay, the alarm has been triggered. I think there's a detail here on which alarm. Is there information here? No, it doesn't say here. But basically, if an alarm is triggered, if there is a thing, in this case, just the duration of the function, longer than 3000 milliseconds, the alarm will be triggered, and it will tell code deploy, roll back that deployment. Something is wrong. This is not good. Please go back. And even though it is serving, in this case, production traffic. So I'm not going to wait here for this to happen because it may take 5 minutes. It may take, as you can see, that the default is increasing slowly. It may take a longer time, so I'm not gonna wait here for this to finish. I'm gonna slowly wrap up, and then maybe we can go back to this to see if it actually has failed or not. So I'm gonna go back to share the other screen once again. Wojtek, can you just flip back to? Thank you very much. Okay, cool. So let's wrap this up. I've said this before, but there are many more types of tests you can do, right? Your end-to-end testing, your functional testing, your user acceptance testing, your load testing, a lot of things. But I have not talked about those things. Of course, we have penetration testing and all the stuff. But today we had a look into some, let's say, more basic tests. Testing stuff in your text editor, testing stuff in your Git repository, your unit test, your integration test, and finally, testing your code in production by monitoring it and doing stuff with it. So, final thoughts. Testing has different purposes in different stages. It's not the same thing. You wouldn't run integration testing in your editor. You can, but why? That's why you do these things. You will not monitor for production metrics on your Docker container running locally. You will not monitor for production and load testing inside of an alpha environment. Testing is absolutely never done. You keep on testing as long as it keeps working. So that at one point you will be sure that even if your code is in production, you are still satisfied with the way it works. And finally, it's very much cheaper to detect broken code earlier. If you spin up your Gamma environments and your pre-productions and whatnot, it costs money to run that. So make sure to catch your errors on early as much as possible. Because, I've made this lovely thing. Bad code is more expensive as it goes down the line. And finally, if you want to learn more about deployment strategies, testing code, and all those kind of fun things, my twin, or my brother from Africa, Cobus Bernard, and myself have done a bunch of videos live on our stream on twitch.tv/AWS on the exact these topics. So if you want to hear two bald guys discussing weird things, how code fails and how you should prevent it, there's a link to the playlist on YouTube with all the videos. It's a great watch. It's a fun thing. We do it every week at Wednesday, and tomorrow Wednesday we have a chat with Ian McCain on the topic of infrastructure as code. So if you want to join us, please do. And last but definitely not least, Jackie, thank you very much for being part of this. Thank you very much for letting me know. And as I mentioned during this entire talk, it's very important to keep on testing even after you're done. So I want to gather some information. I want to gather some metrics. That QR code is the feedback link. So please let me know the feedback. Let me know, did you like this? Did you not enjoy this? What can I do better? I want to make sure that my production is running good. My name has been Darko Mesroš, and thank you very much. Na zdrowie.
Thank you very much, Darko, for the presentation. I don't see any questions besides the discussion about testing of Lambda Edge. It's quite interesting, but
yeah. But okay, if you have any questions, feel free to let us know right now. If not, I'm available on all these things here.
In the meantime, I have a question for you regarding the Lambda testing, actually, because I have seen that you are using serverless application model to your tests, but you are using that for the testing and for defining the function in the cloud formation, actually. I have a question about AWS CDK and testing locally. Are you synthesizing the application, AWS CDK application, and then you using serverless application model for running the code?
Yeah, you can do that as well. In this case, it's just pure like SAM code. I haven't done any CDK part of it. The only CDK part of this is the actual thing that builds the pipeline. I did that in CDK, but the application itself is just written in SAM. I found SAM very easy to do that because it's very easy to attach like your blue-green deploys on, or your canary deploys on a Lambda function that way. Yeah.
Okay, thank you. Wojtek has the question about some tips
load testing
tools.
Okay, I've used the one. So there's a lot of ones out there, like a lot of services out there that you can cover. JMeter does one of those things as well. There's many platforms out there that do that for you, of course, for money. One of the fun ones I've used, and it's a self-hosted one, and I'm not sure if it's really active anymore, but it's called Bees with Machine Guns. Yes. It's an open source project that basically just spins up a massive amount of containers on your AWS account. It keeps on sending load to your system. So Bees with machine guns. Fun thing. Now I'm not a big expert on what is the best load testing system out there, but you can always go with the big ones like JMeter and the like.
Okay.
Well, thank you very much. By the way, the test hasn't failed yet, so I cannot show you. So I apologize. It's just it's very difficult to test things that are running in real time. So yeah, but thank you very much once again.
Yes, thank you very much, and feel invited to the Poland when the offline meetings are.
Yeah, once we get offline once again, please do let me know. I would come even just to listen to somebody else talk. But it's a real shame. I've spoken with a bunch of people from Poland before this entire thing happened, and we were discussing, we're gonna run a bunch of different events, this community days, non-community days. All of these things are gonna happen in Poland, and yeah. So fingers crossed for all of this to pass. We're all healthy and good. And I'll come to Poland to have all the things there.
Yeah.
Thank you very much.
So thank you very much. Thank you once again, Michał and Jacek, for the presentation, and thank you, Darko, for your presentation, and thank you for all of you community members for attending to this meeting. And see you soon on the next meeting. I think I can give you heads ups that the next meeting will be on May for sure. So feel invited to this next meeting.
Excellent. Thank you very much.
Thank you very much, and see you later.
See you all. Bye.
Yeah.